Okay, so if you're a product manager, maybe a marketer, or really anyone who's ever had to greenlight a product based on survey data, you know this pain. You spend thousands, maybe tens of thousands of dollars, wait weeks, only to get back these numbers that are just, well, they're so vague, they barely help you decide anything.
Oh yeah, we call that the billion-dollar problem in the industry.
Mm.
It's not just that traditional market research is expensive and slow, though it definitely is. The real kicker is the muddy signals you get back. Humans, honestly, we're not great survey takers. We do this thing called satisficing.
Satisficing, like you just click the first okay-ish answer.
Exactly. Or you get acquiescence bias.
Yeah.
Probably basically tell you what they think you want to hear, trying to be agreeable.
Right, and that leads to all the answers clumping right there in the middle. It leaves you completely stuck. You get this fuzzy picture, often way too late, just when you need to commit serious money to production and marketing. So, our mission today is to dive into what looks like a really powerful, kind of elegant solution that might just fix this.
We are going deep on synthetic market research, and specifically a new technique that's backed by some really solid research. It's called Semantic Similarity Rating, or SSR.
And this isn't just theory, right? The research we're looking at tested this across, what, 57 actual product surveys?
That's right, 57 real surveys involving over 9,300 unique human participants. And the focus was squarely on predicting, the bottom line, purchase intent.
Okay, lay the headline claim on us then.
Here it is, and this really changes the game. This SSR method can simulate how consumers judge products so accurately. It reaches about 90% of human retest reliability.
90%. Wow. Okay, unpack retest reliability for a sec.
Yeah, good point. It basically means the AI panel's consistency is almost as good as asking the same group of humans the same question twice with a bit of time in between. It's incredibly stable.
That's actually amazing. But hang on, if these large language models, LLMs, are so capable, why didn't this work when people first tried it a couple of years back? I remember hearing about early attempts.
That is the perfect place to kick off. So synthetic market research basically is telling an LLM to role play, act like a synthetic consumer. You give it demographics, age, income, maybe brand preferences, show it a product concept like a picture and description, and then you ask for its reaction.
Okay, makes sense.
But the early attempts were, let's say, a bit naive. They just asked the model, okay, on a scale of 1 to 5, how likely are you to buy this? Give me a number.
Just like a human would tick a box.
Right.
And what happened?
Not great. Disaster might be too strong, but it didn't work well. When you force the model to just output one number, it gets weirdly conservative. The model showed no real conviction. They regressed to the middle. The answers bunched up around 3, maybe 4 on that 5-point scale.
So you ended up with these distributions, the spread of answers that were super narrow, way too middle heavy, and just looked nothing like how real humans actually respond. Humans use the extremes sometimes.
Precise.
Wait, I think I remember seeing some early stats, though. Didn't they still claim some pretty decent correlation numbers? Like 80% of human retest correlation? That sounds okay, doesn't it?
It sounds passable, yeah, but it's really misleading. Correlation only tells you if the average scores are generally moving in the same direction as human scores. It says nothing about the shape of the data, how the answers are spread out. And that spread, the distribution, that's where all the rich insight is hiding.
Okay, right. So correlation could be okay-ish, but the actual pattern of answers was totally wrong. What metric showed that part was broken?
That's where we get a little technical, but we can simplify it. They used a metric called Kolmogorov-Smirnov similarity, or KS similarity.
Okay, KS similarity.
You don't need the math, really. Just know it measures how well the shape of the AI's answer distribution matches the shape of the real human answer distribution. A score of 1.0 means a perfect match. 0.0 means they're completely different.
Got it. So it's measuring the shape, not just the average. And if those early AIs were just giving middle-of-the-road answers, their KS similarity must have been pretty bad.
Exactly. The numbers really spell it out. GPT-4o, the latest model, when forced to give a direct number, it only got a mean KS similarity around 0.26.
Oof. Less than a third of the way to a perfect match.
Yeah. And Gemini 2.0 Flash, another strong model, was a bit better, but still poor, around 0.39. That massive difference, that divergence, it meant the AI was probably thinking about the concept reasonably well, but the second you forced it into that numerical box, the output became unreliable, unusable really for understanding the market spread.
Okay, so the big takeaway here is the problem wasn't necessarily the AI's brain, its underlying intelligence. It was how we were asking the question. The elicitation method was the flaw.
You nailed it. We were essentially forcing the AI to make the same kind of simplification error humans make on surveys, constraining its output way too early.
Which brings us nicely to the breakthrough, the semantic similarity rating, SSR. You said there's a philosophical shift here.
Yes, a really core one. Language first, numbers second. Think about how you decide if you're, say, a 4 out of 5 likely to buy something. You don't just pull the number 4 out of thin air. You mentally list the reasons, right? Well, I like this feature, but the price is a bit high, but I trust the brand. Then you translate those reasons into a score. SSR just mimics that natural thought process.
Okay, I like that framing. Language first. So how does it actually work? You mentioned a 4-step workflow.
Yeah, and it's actually quite elegant. Step one is the big change. Instead of asking the AI for a number, you prompt the synthetic consumer, the role-playing AI, for a free text purchase intent statement.
So you just ask it why, like explain why you would or would not purchase this product based on the concept.
Exactly that. You want its reasoning, its rationale in natural language.
Okay, so the model spits out, I don't know, a paragraph explaining its thoughts.
Yeah.
Then what? We
Yeah.
still need a number eventually, right?
We do. Step two. We need to make that paragraph measurable. So we take that block of text, the rationale, and we embed it. We use a good embedding model. The research used OpenAI's text embedding 3 small, but others could work. This process turns the meaning of the text into a vector, like a point in a high-dimensional space. Think of it as capturing the essence of the rationale mathematically.
Right, okay, so now we have this meaning vector representing the AI's thoughts. Step 3 must be about measuring the purchase intent from that vector.
Precisely. We measure by comparison. We take that thought vector and we compare it to 5 short, predefined reference anchor statements. We create one anchor statement for each point on the Likert scale. So one anchor that means definitely will not buy, one for probably will not buy, all the way up to definitely will buy.
And how do you compare the thought vector to these anchor vectors?
We use something called cosine similarity.
Okay, stop there. Cosine similarity, break that down simply for us non-math folks. What's it actually doing?
Think of it like direction. Imagine each statement, the AI's rationale in each anchor, as an arrow pointing in a certain direction in that meaning space. Cosine similarity just measures how much 2 arrows point in the same direction. A score of 1 means they point exactly the same way, -1 means opposite directions, 0 means they're unrelated, directionally speaking. So if the AI's rationale vector points very strongly in the same direction as the definitely will buy anchor vector, it gets a high cosine similarity score for the 5 category.
Gotcha. So it's measuring how closely the AI's reasoning aligns with the meaning of each potential score. Makes sense. What's step 4?
Step 4 is translating those similarity scores into our final output. But crucially, we don't just pick the highest similarity score and call it a day. We convert all 5 similarity scores into a probability mass function, a PMF, over the 1 to 5 scale.
Whoa. Okay, PMF. So instead of just getting, say, a 4, you get something like, there's a 10% chance this AI persona is really a 3, a 60% chance it's a 4, and a 30% chance it's actually a 5.
Exactly. You get a probability distribution across all possible scores. It captures the nuance, the uncertainty, the potential leanings. It's much richer than a single number.
I can see the value there straight away. That sounds much more like how humans actually feel. Often we're not 100% certain about our rating. The research also mentioned averaging across multiple sets of these anchor statements. Why do that? Why not just stick with one good set?
Good question. That's about stability and reducing variance. Any single set of anchor statements you write, the little phrases defining 1 through 5, might have some accidental bias. Maybe your definitely will buy phrase sounds a bit too enthusiastic, or your neutral phrase sounds slightly negative. By creating several different sets of these 1 to 5 anchors and averaging the resulting PMS you get from each set.
You smooth out any weirdness from one particular phrasing choice?
Exactly. It makes the final mapping from language to the probability distribution much more robust and less dependent on the specific template words you happen to choose.
Okay, so this feels like the moment of truth. Does this relatively simple workflow change language first, then semantic comparison actually deliver? Does it fix the problems of the old method?
It delivers spectacularly. Remember those terrible KS similarity scores, the 0.26 and 0.39?
Yeah, the one showing the shape of the data was all wrong.
With SSR, using the exact same underlying LLMs, the mean KS similarity skyrockets. For GPT-4o, it hits 0.88. For Gemini 2.0 Flash, it's 0.80.
Wow, going from below zero point 0.4 to over zero point 0.8 is a massive leap. But that's saying the AI spread of answers now looks very, very similar to the human spread.
It's an incredibly strong match.
Yeah.
And that improvement in distributional accuracy directly leads to the headline figure we mentioned earlier, reliably hitting about 90% of human retest reliability.
It's hard to overstate how big a deal that is, especially when you compare it to other attempts. The research mentioned a baseline model, right, like a standard machine learning model.
Yeah, they built a strong light GBM model, a type of gradient boosting machine. They trained it only on demographics and maybe some basic product features, the kind of tabular data you'd usually have.
And how well did that do at predicting purchase intent distribution?
It only reached about 65% correlation attainment with human results, significantly worse than the SSR method.
So that really underscores your point. The language, the nuance captured in the why, is fundamentally more predictive here than just knowing someone's age or income bracket.
Absolutely. The language holds the key.
But what gets me really excited here is that SSR isn't just about getting a better, more reliable number on a dashboard. You mentioned the rationales are generated first. That feels like the hidden superpower.
It really is the core value proposition, beyond just the improved score. Think about the pain of reading through actual human survey, open-ended comments.
Oh, yeah. You wade through pages of, it's good, I like it, nice color, maybe one useful comment in 50.
Exactly. The study found that the synthetic, open-text rationales generated by the SSR process were consistently deeper, more specific, and far more actionable, less fluff.
So they weren't just bland agreement, they actually contained usable intelligence. Like what kind of things?
Things like specific concerns about price points relative to perceived value, potential side effects mentioned for a wellness product, skepticism about whether a brand known for X could actually deliver Y, or identifying really specific use case objections that the product team hadn't even considered.
Okay, that is gold because it's structured language, right? You could probably analyze it programmatically.
Precisely. An analyst can take these synthetic rationales, quickly cluster common themes like looks too clinical or worried about cleaning, and directly link those objections back to specific features or claims in the product concept. It means you can spot potential failure modes concepts that are just doomed from the start, super early in the development pipeline. And critically, you have the AI's own words explaining why it's likely to fail.
Imagine the arguments that avoids. Instead of debating opinions, you have data-driven reasons. You could save so much time and budget by killing weak ideas on day one, backed by detailed feedback, instead of months later after vague human responses.
It shifts AI from being just a prediction tool to being a genuine engine for deep consumer insights.
So let's talk about putting this into practice. How does this change the day-to-day or maybe the week-to-week for a product team? The big promise is speed, right?
Absolutely. The biggest impact is operational. This workflow fundamentally changes the iteration cycle. It shifts product testing from being measured in calendar time, weeks, waiting for panels to compute time, hours, or even minutes.
Okay, the research gave a really concrete weekly scenario. Let's walk through that because it makes it super tangible. So it's Monday morning, marketing drops a new concept brief in your lap. Maybe it's a fancy new type of coffee maker. What happens next with SSR?
Okay, first, you define your target synthetic panels. Maybe you want to see how high-income millennials in cities react versus, say, suburban families. You set those demographic profiles, you feed the concept description and maybe an image into the SSR workflow. Within, realistically, under an hour.
An hour. Wow.
Yeah, compute time is fast.
Yeah.
You get back not just a top-line score, but the full PMF distribution for each persona group and all the underlying text rationales.
Okay, and maybe you see right away a common objection popping up in the rationales like, this looks really complicated to clean.
Exactly. So Monday afternoon, your team quickly mocks up a variant, maybe just adding a single line to the concept description. Features a one-touch self-cleaning cycle.
Then you just run it again.
You run it again through SSR with the updated concept. Maybe now you see the average purchase intent score jumps from, say, a 2.9 to a 3.3 for that key demographic. And the hard-to-clean comments disappear from the rationales. Instant feedback.
Okay, so that's concept iteration. What about Tuesday or Wednesday?
Now you're screening variations in copy or maybe packaging designs. Let's say the synthetic comment for one packaging option, keep mentioning it looks too clinical or reminds me of hospital equipment.
Ouch. Okay.
That's direct, actionable feedback. The design team can immediately tweak the color palette or typography, maybe aiming for something warmer. And you rerun SSR to see if that specific objection goes away and if the overall intent improves.
The key here is you're not booking focus groups for every little tweak. You're iterating almost in real time based on this rich AI-generated feedback.
Totally. So by Thursday, you've maybe tested 5 or 6 variations of the concept, the copy, the packaging. You've used the SSR data, both the scores and the rationales, to zero in on the strongest overall contender.
And then you bring in the humans.
Then you reserve your budget for a smaller, more targeted human panel. You use them to validate and confirm the best concept identified through AI screening. Your expensive human feedback is now focused on refinement and final checks, not basic triage.
That makes so much sense. Faster concepts getting to market, fewer internal debates based on gut feeling, and crucially, every score has an explanation attached. That's powerful.
It really changes the dynamic.
Now, whenever we talk about a technology this impactful, especially one involving AI simulating humans, we absolutely have to discuss the guardrails. The big question from stakeholders is always, is this meant to completely replace human market research?
Yeah, and the research paper is very clear and responsible on this point.
Yeah.
Absolutely not. SSR is positioned as a powerful screening tool and an explanation engine. Its purpose is to dramatically reduce the number of full human studies you need to run, and to make the human studies you do run much more focused, efficient, and insightful. It augments human research, it doesn't replace it.
Okay, so it handles the early stage heavy lifting and iteration. But what are the things it can't capture? What are those real-world complexities that still absolutely require human feedback?
Things like sudden cultural shifts, or very specific, timely budget constraints a real person is facing right now. Or maybe unique local events or advertising campaigns that influence a small group but aren't reflected in the AI's general training data. The synthetic consumer is, in a way, an idealized, rational persona based on patterns in vast amounts of text data. It's not a person living through the messy, unpredictable reality of daily life.
That's a critical distinction. And what about domain fit? You mentioned the research focused on things like oral care, where there's lots of public discussion online for the AI to learn from. When should teams be more cautious?
Right. If you're working in a category where the LLM has likely seen tons of relevant public conversation, consumer goods, electronics, maybe common services, SSR tends to work very well. But if you're launching something super niche, maybe a highly specialized B2B software tool with unique jargon, or a cutting-edge medical device, things the general public hasn't discussed widely online.
Then the AI hasn't had much data to learn the specific nuances, the language, the concerns of that specific market.
Exactly. In those thin data domains, the model might struggle to generate truly authentic or deeply insightful rationales. You can still use SSR, but you need much heavier human validation alongside it, and you treat the synthetic output with a bit more skepticism.
So it's about understanding the tool's strengths and limitations. Augmentation, not replacement, and be mindful of the domain. Got it. For teams ready to start implementing this, what are the key best practices highlighted in the research?
Okay, a few crucial ones. First, always, always store and analyze the raw outputs. That means the full probability NAS function, the PMF that spread of probabilities across 1 to 5, and the raw text rationale. Don't just rely on a single average score for your dashboard. The real insights are in the shape of the distribution and the words themselves. The single score is for quick comparisons. The PMF and text are for deep decisions.
Okay, preserve the richness. What else?
Second, when you define those reference anchor statements, the little text snippets that define what a 1, 2, 3, 4, 500 mean semantically, keep them short, generic, and domain neutral. You want them to be reusable across different projects and product categories without introducing weird biases. Don't make them specific to, say, coffee makers, if you might use the same system for testing snacks next week.
Makes sense. Keep the measurement standard consistent. Anything else?
And finally, a good sanity check is to track the KS similarity score itself over time. Compare the KS scores you're getting from SSR against historical human studies you've run in similar categories. If you suddenly see your KS similarities dropping significantly below that .A0 benchmark for a particular concept, it's a warning sign. It might mean your concept or your prompting is pushing the AI panel to behave in ways that are diverging from typical human patterns, and you need to investigate why.
Right. Use the metric itself as a quality control check. That's smart.
So if we tie this all together, going back to the beginning, the big revelation here isn't really about building a fundamentally new, smarter AI. It's about realizing that the incredibly powerful LLMs we already have can give us amazing market insights if we just ask them the right question in the right way.
Yeah, it boils down to that philosophical shift. Ask for the explanation, the language, the why first. Then use smart techniques like semantic comparison to derive a reliable number from that language. It seems like such a simple switch in perspective, but it's the difference between AI market research being a kind of unreliable novelty and becoming actual core infrastructure, a tool you can genuinely use to speed up learning and drastically cut down on wasted effort developing concepts that were never going to fly.
Exactly. And again, the source material is careful to note that even this powerful technique doesn't capture everything. Those real-world contingencies, personal budgets, cultural nuances, ad exposure, those still need human eyes and real-world testing.
Okay, so let's leave our listeners with a final thought to chew on building on that. If this SSR method gets you, let's say, 90% of the reliability of a human panel for early stage concept testing, how do you strategically use that incredible gain in speed and efficiency, that 90% head start, to better investigate and truly understand the final, messy, complex 10% of real-world consumer behavior? What deeper questions can you finally ask? What bolder experiments can you run when you're not constantly bogged down in just triaging basic ideas? That feels like the next frontier this unlocks.